Welcome to ePathshala lecture series in computer science. This is a course in cloud computing. Today we will talk about cloud resource management. So, the learning objectives of today is we will first see the resource usage in cloud. We will look at a provisioning model, how the resources are provisioned typically among the stakeholders. We will then look at the scheduling of cloud, and then we will see how the resource management with respect to scheduling comes, followed by the summary. So, these are the two stakeholders. One side it is the cloud user, and the other side it is the cloud service provider, and the point of contention or the requirement between these two is the computing resources. So, the cloud user would expect or request resources from the cloud service provider for running some kind of application. Now, the cloud service provider will allocate the resource. With respect to that, it will try to maximize the revenue and maximize the utilization of the resources. So, resource becomes the point of contention of the cloud service provider. On the other hand, when these resources are given to the cloud user, the user will consume the resources, but the objective of the cloud users will be that they want to maximize the performance, reduce the finishing time, that means want to finish off as early as possible at the minimum cost possible. So, these the two stakeholders in this system has actually contradicting requirements or objectives, and resource management is how these two objectives are met, and the maximization of everything and the minimization of cost on terms of the user happens. So, let us first understand what exactly we mean by resource management. So, what is a resource? A resource is an item that is used by a consumer. So, here in cloud computing, resource will be a CPU, any kind of computing, storage, network, indirectly they will use the power, all these will be resources. So, resource management will be obviously from the perspective of the resource, that the resources are utilized to the best of its abilities, maximum utilization of resources, and the service provider will lease out this kind of resources to the consumer. The types of resources will be, as we mentioned, there are various types. There are various ways of provisioning these resources. So, the types of resources are compute resource, of course, all the whole collection of physical machines, which includes the processor, the memory, the network interface, all the IO devices that are being used by the user. Total computational capacity of the cloud is the compute resource. Then comes the network resources in terms of how these machines are connected with each other in a data center. So, that is the network resources that and we expect a very high bandwidth, because communication should not waste time at all. The third, and definitely not the least, is the power resources. This is an indirect resource. This is an indirect resource that is being consumed by the user. And data center, typically we have seen in many our discussions that data centers consume very huge large amount of power, and that is always a point of concern. And of course, when we talk about resource management, we have to talk about how the data center manages that. Therefore, reducing the power consumption and how to ensure that power consumption is reduced is also a concern for resource management. So, provisioning types are we know that there are 3 types of clouds. So, these 3 types, how they manage provisioning is what is the point of interest. In when it is the third party is giving all the resources, leasing out all the resources to the consumers, it is the public cloud. When we have a private infrastructure, internally in an individual organization, all the employees of the organization will be using it. That is the resource provisioning in a private cloud. And during cloud burst, during when a private cloud is not capable of giving resources, when a private cloud goes to the public cloud, that is a hybrid cloud, and that has a provisioning mechanism. And in a community cloud, in a decentralized governance is there in a community cloud, that is also a fourth type of provisioning. So, the roles in a cloud resource management scenario are of course of the cloud service providers. They have the hardware, software, and they have a very major role to play. The users, these are enterprise users, as well as individual users also will come. So, enterprise users have a bigger role in a resource management scenario, because they consume more power, and of course, the individual users whose mechanism of consumption is the least, but they come in a very large number to cloud providers. So, therefore, they have to be considered. A fourth type of role will be for a commercial cloud, open source cloud platform that have been applied to the all the industry. So, the industry also plays a role in the cloud. So, so let us look at the resource management. Therefore, the overall process of allocating a resource, which includes all the types, will be the resource management concern. It has to meet the performance objectives. Whose performance objectives are we talking about? It is the application that is running, the performance objective of that. That means there should be enough resource so that it does not run in a suboptimal environment. The service providers performance objectives, that when you follow the SLA and you ensure that your resources are utilized to the maximum at the minimum cost, that has to be seen, and revenue should be high. And service consumers perspective will be maximize the utilization and minimize the cost. So, the first part that we look at is the scheduling, because resource management, a large part of resource management is about scheduling the resources. So, we will first discuss about scheduling, and then we will move on to the overall resource management. So, any system, for any system, scheduling is the core. Let us take a normal uniprocessor computer, a multitasking environment, where scheduling the different tasks is or processes is a very important job. We take a college scenario, there scheduling the classes will be a very important job. So, typically when there are multiple entities involved in any work, scheduling becomes a core part of that system. It goes without saying that cloud being such a huge mass of resources, scheduling and tasks, scheduling becomes a very important aspect. So, therefore, cloud will definitely not be an exception to the fact that scheduling plays a very important role. Advanced and optimized resource scheduling is required, because it is all about sharing resources in an optimized manner. Therefore, scheduling becomes a very important part of it. If I can have a better scheduling mechanism, my overall system efficiency will improve, my performance will improve, my resource utilization will improve, and all the stakeholders in the system will be benefited by that. So, sharing of resources is a very big criteria. So, funnily, among all the other distributed systems, cloud requires more attention. Let's look at the reason for this. In a cluster environment, which is a distributed environment and considered to be quite a complicated environment, a centralized scheduler, because the focus of a cluster is that the overall system performance be improved. So, therefore, they are interested in having a centralized scheduler, and using that centralized scheduler they can perfectly do the job. On the other hand, grid, where the end user's performance, when an application runs, the efficiency with which the application is running is the important part. There they use a distributed scheduler, and hence their objective is met. Unfortunately, cloud has both the objectives. So, we need a centralized scheduler so that a data center is managed, many resources in a data center, many CPUs in the data center is managed properly. Again, we need a distributed scheduler because the customer will expect to access the resources from various parts of the globe, and cloud promises to provide that. So, therefore, we need a distributed scheduler. So, a combination of centralized and distributed scheduler is what is the requirement, and therefore, it is more challenging than a normal other distributed system. So, what are the issues that specifically cloud faces? Many small requests. If there are especially when there is an environment where a SaaS is provided, an application, people use it at the application level. Individual users come and use it at an application level. I want to run a small program, or I want to edit a small document. Therefore, many small requests, scheduling many small requests is obviously much more challenging than scheduling a few large requests. The workload characterization is difficult. We will look at this later part in the module, but it is very difficult to have a characterization of the workload, and therefore, trying to do that is a challenge in an issue in a scheduling part. The type of request, there are many type of resources and different services that are available. Therefore, different types of requests come. Based on that also we have to do the scheduling mechanism. And last but not the least is that there is a real time allocation. So, dynamically users will come and will expect that the resources are provided properly and scheduling happens. Therefore, it is harder. Let us look at the provisioning model. We have the customers who are there are individual customers and there are enterprise customers, and we have the provider. Provider has the infrastructure. These infrastructures, as we have said, all resources are part of this infrastructure. Now, we have the middleware which contains all the necessary activities that a provider has to do. It has data management, interface, hosting, billing, etc. And we have the different types of services that the provider offers. Now, when the customers give jobs that should be run, what they have to do is there has to be a job scheduling which schedules the customer's jobs onto the services. So, various services are there. These services are made available to the customers for each of the jobs. And the other part of it is scheduling these jobs onto the infrastructure, and we take it to a different scheduler which is called the task scheduler, and these task schedulers get the meta task which is an abstraction of these jobs, and they have to schedule it physically onto the infrastructure. This whole part of services, middleware, the task scheduling and the infrastructure belongs to the provider. Job scheduling, while it can be a part of the providers, but not necessarily job needs to be scheduled by the provider. There can be a third party brokers which can schedule a job, but it can be given by the provider also and the customer. So, that is the provisioning model that we have. So, as we saw, there are two types of scheduling that is required in a cloud environment. The first one will be job scheduling and the second one is the task scheduling. So, various names are given to these two methods. It is not a standard name that is used. We will see during this module what are the different names, and various authors would have talked about scheduling in different terms, but essentially these are the two types of scheduling that everybody will be talking about. So, let us take up the first one, job scheduling. This is the job level scheduling where user, as we have seen in our provisioning model, users will submit their jobs. The job has the user's identity. Along with the job, the user's identity comes, and they have different payment models based on the kind of payment they are ready to make and based on the kind of resources they are ready to use. The scheduling has to happen. So, some user may require more computing power, somebody will require a parallel mechanism, someone will require that I pay the least amount for this resources and so on. So, based on that, the job level scheduler has to look at all these constraints with respect to the user. Each job has to be scheduled based on the user's requirement. The job scheduling is called various names: user level scheduling, global scheduling, etc. So, the job scheduler, so what is a mechanism of job scheduling? One very popular method is called a market based scheduling. Various methods are there where the demand and the supply relationship in the resources are looked at, and based on that scheduling will happen. And the second method is auction based method, where in auction based method a set of rules are given by the price is not given by the consumer provider. A set of rules are given by the provider, and based on those rules customers will bid for, it's basically an auction system where customers will bid for, consumers will bid a price, and the best price or the set of rules will define who will win, finally get the resource at what cost. And the last part is the economic scheduler. These economic schedulers are a set of schedulers which takes care of optimizing the resource utilization and the cost. So, these are our typical job schedulers. There are many scheduling mechanisms that are being used. Lot of research is happening in cloud scheduling at this point in time. But these are the basic methods that are available. The next one that we look at is the task scheduling. In task scheduling, as we said, the jobs are submitted by the users, and these jobs become a bunch of tasks for the user, for the providers to be scheduled on the data center infrastructure. So, all these, the physical part of it as well as the virtualized clusters are the infrastructure that has to be scheduled on. So, the different names of a task scheduler that one can come across, it is called a system level scheduling, it is called a local scheduling, it is also called a facility level scheduling. So, what are the possible task schedulers that are being used by the industry today? One is all task schedulers are heuristic, because it is a NP complete problem where it is not possible to find an optimum solution of as many jobs to be scheduled on as many physical machines or infrastructure. So, all possible methods, models are based on some kind of heuristic. There are two types. One is called the static heuristic and the other is the dynamic heuristic. In static, essentially we call them static because all tasks are assumed to be arriving together, and the time that is available after every allocation of a group of jobs or a group of tasks, the available resources will be known. Which is a little impractical because tasks do not come together. If we make the tasks to be submitted together, then maybe we are making a user job wait for a long time, which is not possible or feasible in a cloud environment. Typical examples are min-min algorithm, genetic algorithm, etc. Dynamic are not, they do not assume anything. They assume that tasks will come, and it is basically a mapping between the task and the machine. And also dynamic assumes that some machines may fail, some machines, new machines will be added. So, the whole environment of the task set and the machine set, in case of dynamic, it is dynamic environment. Suffrage is an algorithm that is typically used. So, the third set considers the data intensive jobs, highly data intensive job, where the data becomes the most important part of scheduling. Typically the data intensive work is done in Hadoop, and it is said to be the Microsoft's basic essential engine, which is Dryad, which does quite similar work as Hadoop. Hadoop is the Apache open source mechanism of based on HDFS and MapReduce. Hadoop uses FIFO scheduler. We know from operating systems that FIFO scheduler is first in, first out. Whichever job comes first, whichever job arrives first will be allocated the scheduler. A fair scheduler ensures that every job in the queue gets the fair amount of time. It is some kind of a time sharing. A capacity scheduler has basically it is a queue based scheduling, where each queue will be allocated a certain capacity, and whichever job has been assigned to that queue will get that share of the job. And the fourth is a delay scheduler. Delay scheduler is based on the data availability in a local node. If a job is assigned to a specific node, they try to have a node having the data that is required by the job. So, they will delay a job to an extent, and not really it is an improvement on the fair share scheduling, that is called the delay scheduling. Dryad uses a mechanism called Quincy, which is typically a fair share kind of a scheduling mechanism. Now that we have looked at the scheduling mechanisms, let us look at the overall resource management. Other than scheduling, there are many other functions. In the rest of the discussions, we discuss all of them. These are the functionalities that are to be included in a resource management. Let us take a look at each one. So, global scheduling, as we said, it is the job scheduling. This is a system wide, it is also called system scheduling, system wide allocation of resources to the job submitted by the users. And there are two ways of controlling this. One is a centralized control, where all the jobs will be submitted to a specific controller, and all the resources are controlled by that specific controller. And the other way of doing it is a distributed way of doing it, having a decentralized resource controller. So, what are the concerns in a global scheduling? The virtual machine placement, where to place the virtual machine, provisioning, the network aware virtual machine, the data has to move or the computation has to move. I may need to migrate a virtual machine. All these are network related issues of a global scheduler. Energy, how much energy is it consuming? Can I move a virtual machine to another node which will be energy wise better? Now, resource demand profiling, it is very important to be able to do a demand profiling. where we want to know what is the kind of job that is going to come, so that we know how resources can be kept. Two methods are there, model driven and model free. We can use some statistical method, or we can do a already existing mechanisms. Resource utilization estimation, how much resource is consumed, will be actually consumed by the user, will be resource utilization mechanism, and all these network, storage, power resources will be there. How much of free resources will be available, and it is also helpful for the profiling of the point. Resource pricing and profit, it is from the user's perspective as well as from the provider's perspective. From the users or consumers perspective, they need to reduce the cost, and so based on that they will decide how much resource they are going to use. In SaaS application, shall I migrate all applications or some? In PaaS, use partially some platform, and in IaaS, all the hardware shall I borrow from cloud or not, are the considerations. Provider's perspective is what is the pricing strategy, how much price shall I make so that my resource is consumed properly, in terms of VM in IaaS, in terms of the amount of usage in PaaS, and in terms of number of applications or number of duration of the usage in SaaS. Local scheduling, as we have said, the task becomes user identities are stripped off from the jobs, and they become tasks in the system, and these tasks are scheduled in the say machines. Basically multiple task mapping of task to a machine, and all are heuristic. Application scaling and provisioning, because of the dynamic nature, and because sometimes it will come more resource will be required, sometimes less resource will be required. So therefore application scaling is very difficult in cloud. The number of instances can be looked at. We can look at how much of VM should be deployed, and thereby we can try and make some sense out of it, but it's very difficult to do application scaling. And workload management says the application usage scenario can be looked at for workload, or total workload that is going to come. Again, it is quite similar to the usage of the number of requirements, and we can look at load balancing, we can look at workload control, and we can look at workload management. Finally, the cloud management system, which is basically a reporting kind of scenario where human intervention can be done for basically for the monitoring purpose of the overall system, reporting and monitoring, so that we can say that whether SLAs, service level agreements, have been met by the system or not. So these are the topic on resource management in cloud. So what we looked at today in this module is, we looked at what is resource management, then we looked at the scheduling, why scheduling is important in resource management, why scheduling takes the most important role in resource management. We looked at the two types of scheduling that is applicable in cloud, and we saw that there are various names in which it is called. First is the job scheduling, and second is the task scheduling, and we looked at the different tasks that are there besides scheduling in resource management. In the next class, in the next module, we will look at the storage and the importance of storage in a cloud environment. These are our references. Thank you.